Hi, and welcome back to Gavin's Sonex B. Well, as you gathered in the last video, pretty much finished the layout and assembly of the instrument panel, and tried it out in the aircraft, and it fits. So the next thing to think about is actually wiring it, and so I've spent a couple of days working on some diagrams to help me wire it all together. Now the tail cone is already wired, and I brought that to 4 D-type, 9-way D-type connectors, which are situated just behind the seats in the cockpit. And so I've got to wire forwards from there, and so I split the diagram into 2 pieces. The journey from the tail cone interface to the instrument panel, and then to the firewall, and then the bit in front of the firewall I've got a separate diagram for, just to keep it simple. So what have I come up with? Well, here it is. So this is where we've got the 4 connectors behind the seat in the cockpit, and 1, 2, 3, 4. And the wiring from those is pretty straightforward, because one connector is for the flaps, and that goes straight to the E-flaps controller. I've written down here which colours, I don't know which pins actually I used on the connector. I've got to go out in the garage and have a look. And then we've got the TC90 controller for the radio, which has a number of connections that come to it. The TC20 controller for the transponder, and that has a number of connections that come to it. And then we've got the CAN bus from the MGL sensors at the back, coming forwards, connecting to the EFIS and EMS units on the instrument panel. The EFIS has a couple of sensors attached to it. One is the satellite navigator aerial, and the other is the outside air temperature sender. And then this is basically our switches and fuses. So we've got main power coming in from the battery through a 20 amp, well, I've set it as a 20 amp at the moment. We'll see whether that's enough or too much. Then the master switch. This then becomes our feed for everything, basically. So we've got power going off via a resettable fuse to the E-flaps controller. We've got power via another fuse and a switch to our radio equipment, so all the comms. And then we've got power via another fuse running some auxiliary stuff like the turbo cooler system and the power feed for the coils for the engine, and that's about it really. We've got the fuel sender, which is in the cockpit area, and that's going out towards the firewall. So these are the connections that are going through our firewall. There aren't many of them. We've got 4 for the MGL CAN bus connections. That includes the power for the RDAC unit, and the fuel level sensor feed to the RDAC, the power for the either the manual override or automatic operation of the turbo cooler. Then we've got the feed for our ignition system, secondary ignition system, our two mag P lines, which basically when you ground them stops the mags from working. And then 12 volts and 0 volts coming through from our battery supply basically. And that's pretty much it. We've got a couple of other ancillary bits on there, the USB and power outlets, and I think that's pretty much it. I've got the voltmeter on the panel, which just lights up when we turn on the master switch. I'm going to put a nice big capacitor back there as well to basically take out any electrical interference. And so going forwards of the firewall, it looks a little bit more complicated actually, but it isn't really. We've got our bus and power going to our RDAC unit. Our RDAC unit has its sensors coming in. These are all the temperature sensors. So we've got 4 EGTs, 4 CHT inputs. Then we've got, I'm going to put a temperature sensor for the turbo cooler, and that is going to go in on a spare input. Then we've got the oil temperature, oil pressure senders, which get connected to it as well, and we've got the fuel level coming in from the fuel level sender, and then we've got the RPM tacho input, which is coming from the alternator. And so working back down here, we've got the turbo cooling system. So one feed goes through the thermostat, which is the auto operation, and then one feed going direct to the fan for the override. We've got our alternator, which is feeding our 12 volt regulator. The output from that is going to the battery. We've then got our starter switch input coming in, which goes to the solenoid on the starter, and then we've got our starter connected directly to the battery, and then from the battery going back into the cockpit to our main fuse. Over here we've got the coil ignition system, so we've got a feed coming in from the coil switch, which is feeding the electricity, or 12 volts, to our 2 triggers and 2 coils, which are generating these secondary sparks. The 2 mags are sitting here with the 2 P lines going off to basically short them out to turn them off. And that's really all there is to it. It's not a lot. Keeping the wiring down to the minimum. Don't want it to be too complicated. I've spent some time calculating the wire gauges. That's quite important. Whatever you decide that you're going to need supply wise for your equipment is important. Once you've picked the fuse size that you're going to use for that supply, that all the wires that come from that fuse are the right gauge, because if they're too small, they will act as a fuse themselves, which will involve them getting extremely hot and catching fire probably. So if you're going to use a 10 amp fuse to supply a few things, each of those items have got to have a supply wire gauge capable of taking the 10 amps, even though the equipment on the end doesn't require it. Just in case of a short or something like that, you want the fuse to blow first rather than the cable. So I've done a little bit of calculation. I've worked out the consumption of all the different bits of kit, and been online and worked out the wire sizes for various sizes. Let me turn the camera. I've worked out the diameter versus standard wire gauge, and also the millimeters squared area of the conductors for each one. Then I've worked out from some information I found on the internet from the FAA the wire gauges, minimum wire gauges for each size of fuse that I've got, and as you can see, if it's a 5 amp you want at least 20 gauge, if it's 10 amp you want at least 16 gauge, if it's 20 amp you want at least 12 gauge, if it's 30 amps you need at least 10 gauge, and that's based on when they're running at those amperages, that there is a maximum temperature increase and a maximum volt drop across those cables for a given length. And it's all very complicated because it's all down to lengths and cross-sectional areas and voltages, and if you're like me, I just went online and downloaded a couple of handy charts from people who'd already done all this kind of stuff, and then worked it out what wire gauges to use for what, basically. And so that's what I've been doing the last couple of days. What's next? I'm going out into the garage because I've now ordered all the cable, some connectors that I didn't have, another crimper for crimping on the ferrule ends on cables. You'll see when that arrives what that does, and they won't be here for a week, 10 days maybe, so I'm going back out in the garage to finish the engine. I've also taken the turbo cooler header tank off to the aluminium welder guy, who's only just down the road here, literally about less than a mile away, and he's going to modify it the way that I want it modified, so it does what I want it to do. So that's gone as well. So for the next 10 days or so I can't do any wiring because I need it all here before I start, and so I'm going to finish off the engine and we'll sort out the rest of the oil pipe work and cut those pesky push rods for the last time, hopefully. More later.